In this competition, there'll be two challenges. The first challenge I will face will need two people, the human player device and the teleoperator. The first thing we'll need to do is to load a bot into the human player device, and it would be placed into the catapult system that the robot has. Once it's loaded, the teleoperator will drive the robot into place and shoot the ball and try to make it into a basket. The more golf balls we shoot, the more points we get. For the second challenge, it's autonomous mode. Well, the robot will be placed in a specific spot and will be turned on. Once it's turned on, the robot will drive itself and to collect the ball. Once it collects the ball, it will drive to a specific location. And once it reaches that location, it will make a noise, then it will back up, and it will drop the ball.
Research and brainstorm robot design ideas and human player device. The research I conducted was design a robot with interchangeable attachments, and the human player device is a structure that helps put the ball on the robot, and the player drops the ball into it, and then it falls onto the robot. This makes loading easier and faster.
For our human player device, we decided to adapt a sort of suspension system to keep it from bobbling back and forth when in use. Additionally, it has two tires filled with nuts and washers to add weight to assist not toppling over. Our human player device is fitted with a modified cone with bumps at the ends so that it can slow down our ball movement and allow for greater control through the human player device to our robot.
Some obstacles we encountered while working on the robot were problems with the catapult and ball launching. There were times when the catapult we used was too unstable or easily broken. In order to fix this problem, we had to redesign and 3D print a new one. We frequently altered the design until we had an efficient catapult. On occasions, the ball launching was too fast or too slow. In order to fix this problem, the coder had to modify some parts of the coding until the launching velocity and angle were precise.
Our robot is equipped with custom claws so that it may efficiently grab balls and squeeze them together, therefore not allowing them to move around and free themselves from the claw. Additionally, our tires are sort of custom, with them having the rubber of a medium-sized tire, but they're actually filled by a large red gear so that we can get the best mix of size and traction and not have any slippage when we're moving around. And finally, our catapult arm design is fully custom, with the first piece connecting the catapult arm and the robot, and our second piece, the actual catapult arm, being made of a 3D printed part and the tip of our previously mentioned cone. This allows for the lightest weight and most power to go through our catapult, and it also allows us to catch more balls coming out of the human player device with the improved cup. We can see in this demonstration, our robot has many different capabilities that we have programmed into it. It can move forward, back, and around at first a normal speed, or a really fast speed, and finally a really slow adjusting speed to help us align ourselves with the human player device. When we're ready to align ourselves and receive a ball, we have programmed the feature to be able to lift our arm just enough so that the movement of the ball down to the catapult arm is seamless and has very little margin for error. Once we're ready to use our catapult, we can move around at whatever speed we'd like without the ball falling out, and then launch our ball.
Robotics is used in sports in many ways. One example on how they are used is to umpire a match or a game. They are used to make a call on close or precise situations. They are often effective and used for this reason. Another example of how technology is used in sports is to help people with disabilities participate in any sport. A third way that robotics is used in sports is by recording with cameras from various angles. This can help viewers have a better view and experience while watching sports.
Two real-world areas where robots are mostly used, one of them being healthcare. Robots are used in hospitals to help doctors perform surgeries, deliver medicine, and assist patients. Surgical robots help doctors be more precise, which can make surgery safer and recovery faster. The second one is manufacturing. Robots are commonly used in factories to build cars, electronics, and other products. They can weld, assemble parts, and package items quickly and accurately, helping companies produce goods efficiently.
These are the two main variables used in our autonomous mode. Square found is a variable that keeps a Boolean value of whether we have found the red square or not. Start 40 challenge is a variable that helps us check whether we should be in the mode to do the 40 PT challenge or stay in autonomous mode.
Here we are checking for whether or not the square has previously been found. At the start, it will be false. Next, we want to check whether the color sensor is detecting red by color sensing for the hue under 12. If this is true, then we'll keep moving forward.
This bit of code says, while not run counter is greater than 1, look for square. And this is calling our look for square function, which is pretty much all of the code that has been shown before this. It says that if we have not been able to find our square with the square found variable from earlier, then we want to keep looking for square until run counter is updated, and our square is found.
Here we are checking what color the sensor is reading and making sure it's true red. The sensors read around the number 13, but can also read by mixing colors and getting a red of nearly 300. So we divide what the sensor picks up, and if it is less than 5.5-ish, then we know it's red of the square. After that, we say square found. This is our works cited. This concludes our video.